So that is pretty much the foundation or the basic idea that we were going to play with. And now let us try an example where that idea is not stated explicitly, that try and find the factors and try and pair them. The question is different altogether, and the question will look something like this maybe. I'll say A into B gives you 324. How many solutions for this? And I further define it as how many distinct solutions and how many distinct natural number solutions. This could change, this could be whole or this could be integer, but as of now I'm saying how many distinct natural number solutions for this equation. So first of all, don't get scared, try our time and tested method of trying it with a small number, a small situation. A into B 324, 1 into 324 is 324. Is this a solution? Yes. A equal to 1, B is equal to 324. Even before you start with the problem, know what the problem means. It is asking you how many ways can you write this. Can I rewrite this as 324 into 1 also? And is that important? Yes, because the question was about A and B. So this is A is equal to 1 and B is equal to 324, and this solution will be A equal to 324 and B equal to 1. So first I notice, I try it out and I understand what is it saying. This is one solution, this is another solution. 2 into 162 will also give me 324. 162 into 2 will also give you 324. A is equal to 2 and B is equal to 162. A is equal to 162 and B is equal to 2, right? So the extra thing that is happening here is that I have to count double. That means if I look at a solution, I must reorganize it and think again. But otherwise, I should notice this is nothing but first factor, last factor, second factor, second last factor. So my question is, how many pairs of factors can I form? If the question now is about how many pairs, that means I'll need to find the number of factors for this. Let's do that quickly. Before finding the number of factors, I must factorize it, and the factorized form of this number would be 2 square into 3 raised to 4. 81 into 4 gives you 324. This step I am taking very quickly because we have already done enough of factorization, but you should slow down and figure out whether this is true or not. Once I have this, I can find the number of factors 2 plus 1 into 4 plus 1, which gives you the number of factors as 15. Number of factors is 15. What does that mean? You have 15 factors. First thing to notice is that this is not even. That means everything will not be paired. What will be the problem? The middle term will be the problem. It will be multiplied by itself to get to the original number, right? So I notice that part. But if I don't worry about the middle term right now, I can see I will be able to form 7 pairs, right? First term, last term, second last term. Out of those 15 numbers, 14 can be paired up into 7 pairs. So the number of pairs so far is 7. Now go back to that original idea. 1 into 324, a single pair was giving you two different solutions, right? Why? Because A and B are mentioned. Had it just been two numbers, maybe you would not have to count this. Each solution has to be multiplied by 2, or it can be done in 2 ways. So 7 into 2. So my answer so far is it can be done in 14 ways. You will get 14 different ways of writing A into B is equal to 324. What would be the ways? 1 into 324, 324 into 1, 2 ways, 2 into 162, 162 into 2, 2 ways, right? What are you doing? You are counting how many pairs. That meant one way, and each way meant 2 situations for you, right? Now what do I do about the middle term? The middle term is the square root of this. That means the middle term is going to be 2 into 3 square. 2 into 3 square into 2 into 3 square will give you the same number as 324. But whatever this number is, let's call it P, right? A and B both would be P. And it said distinct. That means A and B should be different from each other. So I will not count that solution. And my number of solutions for this equation would be 14. Right? So slow down, hit pause, rewind and try and understand what is happening. We are essentially saying we learned this idea of pairing. Now we are noticing, okay, we can use that idea in such a question because I could not have solved this equation straight away. A into B is equal to 324 will have very many solutions. So therefore there was no way of solving it. There were many solutions. I should know that by trying out a couple of solutions. And how do I find how many? I use the idea that the pair of factors was going to give me original numbers. I found 7 pairs. That meant 14 solutions. Why? Because each pair can be reorganized in 2 ways. The middle term was unusable to me in this case because my question said there should be a distinct number, right? So I hope with this example we're getting the idea of how we'll use this number of factors and the arrangement of factors in trying to find number of solutions for a given equation. We'll not find one solution, we're looking at how many solutions will be there. And the key idea in all such future questions is going to be this idea that the pair of factors gives you the number. So the question essentially is about factorization, but it is hidden and the language of the question says find the number of solutions. So hopefully we should be able to connect these two ideas together. If the question changes from natural numbers to integers, what would be the change in answers? That is the homework for you. We were thinking of natural numbers, but if I say integers are allowed, then what all is allowed? The thing to notice is you can also now use minus 1 into minus 324, you will get 324. So that means what was one solution now is becoming two solutions. In fact, you can also do minus 324 into minus 1. So one solution is becoming 4 solutions. And why? Simply because of a change of language from natural number to saying integer, right? So you have to be aware of these basic things. And if you look at it now, things are getting slightly complicated, but overall we are using very small different ideas. Number of factors, even, odd, pairing, and then using all of them together in trying to solve this equation fairly easily, right? So this is it for the day. Sit down with the idea, try and do it for a few factors and see the pairing, and then use it for a couple of questions like this, try and figure it out for yourself. In the next session, we'll take this idea and try and extend it further and look at as a number as a difference of two squares, right? A square minus B square is equal to 324. It would not be too difficult. A square minus B square means A plus B into A minus B. Once again, a product of two numbers. And that is a fundamental idea that we are trying to learn. A number as a product of two numbers, both of them are obviously going to be factors. So this is it for the day. I hope this made sense. This is just the foundation. In the next session onwards, we'll apply it, learn the application, and then move into practice territory. So see you really soon.